All right, we are live. Hi, folks. Welcome back. This is episode 3 of Emergence Chats, where we have in depth technical chats about AI agents with the engineering folks at Emergence. I am your host. My name is Vivek Haldar. I lead some of our AI engineering teams. And let's go around the room for a quick set of introductions. Jeremy, this is your second time on the podcast, so welcome back. You were on episode 1 about memory, and Raquib is joining us for the first time. So let's go around. Raquib, why don't you start?
Hey, I'm Raquib. I work at Emergence in the planning team, more specifically agentic planning, where we design systems for LLM-based planning for agentic tasks, workflows, etc. And that's pretty much what I work on.
Awesome.
Jeremy, you want to
Thanks,
go next?
Raquib. Jeremy, go ahead.
I'm Jeremy. I'm a research engineer at Emergence. I work on planning, memory, in agentic systems.
Fantastic. All right. So that is the focus of our chat today. We want to talk about planning in agentic systems, in multi-agent systems. So let's just start off with, what even planning is. So here at Emergence, we're building multi-agent systems. We're building a platform to create and manage and orchestrate multi-agent systems. And of course, planning is a key part of that. But let's just set the stage first. Let's start with what is planning? Why is it important? Why would we even care about spending so much time and effort on planning?
So planning in agentic systems is basically the process of structuring step-by-step actions over time to achieve some goal, often under conditions of some uncertainty. Why is that important? Well, if you're looking to interact with agentic systems in a way that achieves your goals as an end user, you want the agentic system to have some ability to plan, and the ability to plan kind of becomes more important as those goals become more complex. So if we're looking to pursue complex goals and to work with agentic systems that can achieve those complex goals, planning is crucial.
That's pretty good. Yeah.
So that's a good overview. You want to plan your way through complex goals. So let's dig into a little bit about what changed. So with LLMs, of course, there was a step function in this, right? And why do you think LLMs caused that step function? What is it about LLMs in particular that makes planning accessible now?
So when Transformer got introduced initially, then came the LLMs. In those LLMs, it was just it still is just next token prediction model. But after that, then came the instruct models, LLMs, which is the same as next token prediction, but now it's more aligned towards following instructions, user messages, system messages, those kinds of things. But even that was not enough. That's when the tool calling came, which is again a modified version of the instruct LLM. And it does support more than just user and assistant message, but rather it supports tool calling, right? So that's why now we have this need for planning, because when you do have support for tool calling, you can do complex tasks. But to do those complex tasks, you need to be able to do planning. You need to be able to think step by step and perform those actions step by step. And based on the responses of those actions, you want to take probably a different path of actions. So yeah, does that answer your question?
Right,
Vivek?
right. That makes sense. Yeah. So, when we read about agentic systems, I've seen that people often mention planning and reasoning together. And of course, they're related to some extent. But let's dig into that distinction a little bit. In your minds, do you think there's a finer distinction between planning and reasoning? If so, like, what are the different roles of planning and reasoning in an agentic system?
Yeah, so I'll take a stab at that. So I think reasoning is one kind of core component of planning in an agentic system, and reasoning operates over kind of various other inputs to the agentic system. So the other inputs might be goals, maybe expressed by the prompt that the user gives to the system, or maybe given internally as subcomponents. Some kind of action model, so like what the agent can do, how actions that the agent can take kind of might affect the system or affect the world, and those might be represented by the descriptions of the tools that are available. And then finally, any knowledge about the particular domain or world that the agent is acting upon, those also are inputs to the kind of to the reasoning system. So I view reasoning as the kind of the system that operates over all these other inputs to the planning system.
All right, makes sense. Okay, so we are building, multi-agent systems. In a multi-agent system, you have tools, you have other agents, and the plan really is what is tying all of these together. Do you see any difference in planning over tools versus planning over agents? Or, from the point of view of the plan, it's the same, they're all just sub steps?
Yeah, I mean, I think I can answer that. So to an LLM, it doesn't really matter whether it's an agent or it's a tool, right? So all it can do is just invoke some function or invoke some tool. So from the LLM's perspective, what that tool does or agent does is not like transparent to the LLM, right? So it just knows that, hey, this agent has this functionality, so it just invokes it. Whether inside that agent, whether it's a bunch of tool calls or whether it's just a single tool call, doesn't really matter. There are different protocols, however, like MCP protocol for invoking tools, and then A2A protocol for invoking agents. But to an LLM, when you are, if you look underneath the LLM, I think it's the same as, a tool calling, even you are invoking agents.
Yeah, makes sense. Okay, so up until now, we've been. Yeah, Jeremy, sorry, go ahead.
Yeah, just to build on kind of what Raquib was saying, one distinction between agents and tools might be that agents themselves have the ability to kind of do some internal planning. So even though to the LLM, as Raquib said, right, any tools that it has kind of are of the same status, the internal structure of those tools might be quite different. So some tools might, be complex enough that they have their own internal planning systems, and those are the tools that we might want to, call agents. So in that case, there would be some kind of hierarchy to the planning. You'd have maybe a central planner that kind of plans how to use those tools and what instructions to give them. And then any given tool operating on a certain instruction might do its own internal planning.
Yeah, that's great. You're foreshadowing the notion of hierarchical planning, and we'll come to that. But let's peel back one more layer. Up until now, we've been talking about planning somewhat in the abstract. So let's get into a bit more detail on what are the types of planning, because there's different ways you could go about it.
So if I had to take so this is a very complex question, but if I had to answer that, like the current most popular type of planning is like you have a thinking step, and then you have some tool calls in React style. That's like the most popular now, but it doesn't have to be like that. So are you referring to these kinds of types or some
Yeah,
other
exactly.
type?
What are the kind of main kind of paradigms of planning? Like you're saying, like thinking and reacting is one, and then there's a few
Yeah.
others, right?
Yeah, there are a bunch of others. None of them kind of really took off, but I have seen papers where they have designed their own kind of formalism of defining, actions and reactions. For example, the workbench paper, even that one does have their own way of invoking tools. But React is the most popular now, but it also does have some limitations. For example, it's only a sequential steps of plan, so you don't have like branching or other kinds of stuff. So yeah, I mean, types of planning, it doesn't have to be just React. Everybody has their own types, used to have at least. Now everybody's leaning more towards React.
Yeah, I would say, one advantage of the React approach is that it's quite dynamic. So the output of any previous step can be considered, and the next step kind of can easily depend on the outcome of a previous step. So that's kind of a property that you would want a flexible planning system to have. But at the flip side of that is that it's not very deterministic, and sometimes when determinism is called for, it might not be the best approach. So you might want to have a system where a kind of static plan is generated and then executed kind of step by step in a very deterministic way, and that has kind of the opposite trade-off. It's quite suitable for systems that that require a high degree of determinism, but it's less reactive. It's less able to deal with uncertainties in tool results and the like.
Yeah, so that's a great point. So talk a bit more about that, because this trade-off between dynamicity and determinism is something that's super important for enterprises. Almost always, enterprises will want to lean much stronger in the direction of determinism. But then, of course, there's scenarios where you do want some dynamicity with some very complex problem that you haven't seen before and so on. And this is something we've been grappling with for a while. We've tried a bunch of different approaches. So talk a bit more about that trade-off, both between like with React style planning versus more deterministic planning. How does that trade-off work?
Yeah, Raquib, do you want to talk a little about that?
Yeah, so just wanted to clarify, what do you mean by deterministic planning? Do you have some examples?
Yeah, so this is going to what Jeremy was saying at the end, where sometimes you have a series of steps that you want to be followed, right? And not
Right.
have
Oh, I
the
see.
model propose a plan at runtime.
Yeah.
And it's almost like you know a plan up front
Hmm. Hmm.
versus you don't know a plan up front. And there's a spectrum between these two extremes.
Right. So the obvious first difference I see is that for React style planning, it can be dynamic, right? So it doesn't have to follow an exact path every time. It can, take different paths based on the outputs of the intermediate action results. Uh, and then the other obvious advantage is that you can rely on natural text um, queries and outputs of those tools, which the LLM can look at and think about that and then take the next step. Whereas in the deterministic approach, you have um, a fixed set of steps, right? And you cannot really have like arbitrary number of outputs. Arbitrary outputs, which if you don't have a way to parse those, then you can't really know that what to do in the next step. So you need to have like a structured flow of data between the steps in the deterministic planning. Um, but yeah, for React style, it doesn't have to be that in that particular structure. It can be any kind of natural text. Even if it's a structure, then it might also work. There might be more other differences, but to me, these two are the biggest reasons why I wanna like switch to React style planning instead of having a fixed set of workflow.
Makes sense. So, something we put a pin on a bit earlier in the conversation was this notion of hierarchical planning. In the
Mhm.
previous episode of our Emergence Chats, we had spoken with the creators of the web automation agent, Agent E, and that in and of itself is doing a lot of detailed planning to execute in the browser over many pages and reasoning over those pages and so on. But then the web agent itself is one of the agents in our higher level multi agent system. So, talk a little bit more about that. This notion of hierarchical planning. It's almost like turtles all the way down. It's a tree, right?
Yeah, so I think our web agent is a good example of that. Just as you said, Vivek. So there are cases where you might want the tools available to the central planner, the kind of executive function of the system, to be quite coarse grained. So maybe browser use is one of those tools. But the kind of tools that are the kind of base level tools that the browser use depends on, say reading a DOM representation, or clicking on an element, or navigating to a site. You might not want those tools to be all available in the kind of flat structured way to the central planner. And a kind of way of balancing those is exactly how we handle this with the web agent. So the central planner kind of recognizes that one step in the overall plan is to direct the web agent to do some task, and it does it with an instruction. So the task might be, show me the top 5 news articles on Hacker News, right? And that's what that's what the web agent is told. And as far as the central planner is concerned, that's the step in the plan. But then when the web agent goes to to execute that task, it's actually doing some finer grained planning, because in the web agent's perspective, that task, which was atomic to the central planner, is actually consisting of several different steps, right? Navigating to the site, parsing the information on that site, and then what's returned to the central planner is just the output of the web agent steps. And to touch on what something that Raquib brought up before about trade-offs, that approach has advantages and disadvantages. One advantage is that the central planner does not have to deal with the plethora of really fine-grained tools that might overwhelm it, right? It doesn't need to deal with DOM reading or clicking on individual website elements. But one disadvantage is that sometimes information can get lost. So there's some opacity between the actions of the web agent and what's available to the central planner.
Yeah, that's a good point. I think it mirrors the age-old design of abstractions that programmers have to deal with, right? How much, for example, when you're designing a class or an API, how much do you abstract versus how much do you let through the API? And it's always a fine balance, like they say. There are no solutions; they're just trade-offs. And I think that's where design comes in. That's where you have to be very thoughtful about the design of these abstractions in terms of what's hidden, what's made visible, and so on. Okay, so we've talked a fair bit about planning, and now let's turn a bit more towards being data-driven and rigorous. So, of course, anytime we're building an agentic system or elements of an agentic system, we want to have some notion of evaluating it. So let's turn to that. How do we measure or evaluate the effectiveness or accuracy of a planning system? Or what are even good measures to look at when building a planner?
Yeah, I think I can. So me and Jeremy, we both can add a little on that. So one of the things we tried before was having some queries and a fixed static kind of states of the users database. And based on those static states, we ask, so the user asks a question, and then that question only can produce a single answer based on the state that the database is currently in, right? And to find that answer, you may have to proceed with multiple steps in the database calls, or API calls or other tool calls. But even after you do all of those steps, you should always converge with the same answer every time. So that's how we manipulate the environment to have a static state. And when we invoke that our platform with that question, we expect it to produce the same answer every time. That's how we run a little benchmark where we compare the previous state before asking the question versus the state that the LLM has produced after that. So it may have called a database, it may have modified the database, it may have called an API. So we compare these two states. So these two states are basically what the difference between these two states are basically what the ground truth is, right? So we have a ground truth between the ground truth for the diffs, and then we have the actual diffs. So if you compare these two diffs, we can basically say whether the LLM did the right sequence of steps or not. So the sequence of steps can, vary. Like you can have one API call before the other, but eventually it should end up with the same state. If it's not doing that, then it's probably doing wrong sequences of steps. So that's how we, benchmarked our system earlier. And then there are other papers as well who do the things differently. Instead of checking the diffs of states, they actually check the outputs and then compare with the ground truths, which may be a little problematic in some cases, but works well for other cases. Yeah, so there are a lot of trade-offs between each approaches. But I think, based on our testing with Jeremy and me, we found comparing the diffs between the states are better suited for our planner, I think.
Yeah, just to add to that, I mean, even though that may seem like an unintuitive approach, like, constructing this kind of toy world where there's a fixed database and some changes that can be made to it, and comparing the final results of those changes. The reason that's necessary is because when interacting with the real world, things change all the time. So the ground truth answer for what are the top 5 articles on Hacker News might be different this evening from what it is today. So to do proper evaluations, one good strategy is to construct these kind of very fixed data sets.
Yeah, I totally feel that, benchmarking these kinds of systems is so hard. It's such a wicked problem because, like you said, you have to hold something still in order to measure it. But of course, the real world doesn't have that property of things being still. And
Yeah,
I almost
exactly.
feel like these systems are now getting to the level of almost being a cognitive partner, like a colleague almost. And of course, when you collaborate with your colleagues and teams that you work with, you don't go around like scoring and rating them after every interaction, right? It's something much more drawn out.
Yeah.
So I think that might still be an open problem.
Yeah.
Yeah. So let's talk about the interaction of planning with some of these kind of other considerations in an agentic system. In episode 1, we spoke about memory and how important memory is in building these multi-agent systems and actually having them get specialized to your domain and your set of problems. So let's talk a little bit about that. What do you think is the interaction between planning and memory, and what are the cool things you can do when you try to bring those two together?
Yeah, I think I'll take a first stab at this, and Raquib can maybe add some more. When we talk about memory interacting with planning, I think there are maybe 2 systems of memory that planning interacts with. There's the kind of short-term memory of keeping track of recent actions and partial plans, and that in our system is kind of internal to the planner. But then there's also long-term memory, right? Accumulating knowledge of what has worked and what has failed in previous attempts, and also the kind of domain knowledge about the particular domains you're working with that needs to be taken into account by the planner. So long-term memory in particular, gives the planner some ability to learn over multiple attempts. So say a plan that seems reasonable at first turns out to have failed on past attempts. Next time a similar input is given, the planner might invoke the long-term memory and come up with a better plan the next time. And then one additional issue there is, the invocation of the memory itself, the use of the memory system can itself be a tool that the planner has in its arsenal, so that the planner can kind of be agentic in that sense, and that it's kind of thinking, all right, do I know exactly how to do this? Maybe not. Let me kind of consult what has worked in the past. So I'm going to call a tool to retrieve, memories. Does that happen automatically, or does it happen kind of in a kind of dynamic, agentic way?
Cool. Yeah. I think that frontier is particularly exciting. So let's try to wrap with looking forward a little bit. If you think about the difficult problems that are open in planning, what are those? What are the big thorny problems that you're seeing with planning that, if solved, would really improve agentic systems?
Okay, where do I start? So there it's definitely not perfect. Like none of the planners out there are really perfect, because if they were perfect, then you wouldn't have to reprompt ever. So so the current problems are like endless, but the the focus that we are putting on right now are, how do we make it so that the orchestration between the central planner and the other agents and the tools are they happen in a way that the agents, the sub agents, I mean, they get enough information, enough context about what is the task that they're supposed to do and in what way. So this is more like a context lost between two sub agents. That's one of the problems. So sometimes, I mean, it's really hard to tell the LLM like what is the exact kind of context you should send to other agents. So if it's just a tool call, then we do have a specific set of inputs and their types, data types, so that this problem doesn't happen over there. But if you are speaking to a sub agent which expects natural text instructions, then this problem appears where sometimes the central LLM doesn't share the most relevant information to the sub agent. So that's one of the biggest problem that we're trying to solve. And the other problems are like, with React, you have this a single path where you are taking steps, actions, and reflecting, and then taking more action. So you don't have a way to like run loops or run if else branching kind of thing, or even run like multiple branches in parallel, right? So that's one of the challenge, I think, is that you cannot run like planning in a way that it can do multiple things at the same time. It always waits for output from one action before proceeding to the next action. And it's good in some cases, but sometimes you do need like a way to have more versatile kind of workflows within the planning, right? So that's the other challenge. I don't know, Jeremy, if you had other challenges you want to bring up.
Yeah, just to build on what Raquib was saying, I guess some other challenges are and how best to ensure consistency of the plans over multiple runs. So this gets back to the determinism issue. Some things we're exploring are kind of retrieving previously successful plans into the context window in order to achieve a higher degree of consistency while still maintaining the kind of dynamicity of the plans that are generated. I had one more that I was going to mention. Oh yeah, evaluating planning systems over different sets of tools is a challenge. So as our set of tools kind of constantly expands and changes, we want to have a planning system that is not just good for one particular fixed set of tools, but is actually robust enough that it can kind of handle updated sets of tools, expanded sets of capabilities in a natural way.
Yeah, that makes a lot of sense. Yeah, it's a challenging and very kind of intellectually stimulating field to work on for sure. Okay, that was kind of a broad, quick tour through planning in agentic systems. Before we wrap up, any big thing we didn't talk about, something we missed, something we should have talked about?
Yeah, go ahead.
The other thing that maybe we didn't touch on that has become important to us recently is maybe the importance of human in the loop processes in the planning procedure.
Right, yeah. Go for it. Yeah, you're right. We didn't talk about that, and that is an important consideration. So yeah, go for it.
This ranges, everything from vagueness in the initial request. Maybe the user makes, some request that requires some clarification. That's got to be handled. And in our current system, the planner is what handles that. Maybe the first step in executing a user's request is not to jump into planning right away or not to jump into tool use right away, but instead to ask the user some questions about kind of what she meant by this, or kind of which route to take. Another kind of thing that falls into this umbrella is sometimes the tools themselves will kind of return an error or some kind of error that requires clarification, and then that error or request for clarification needs to be kind of passed back to the user, and then the user message kind of passed back to the agent. That in our system is handled by the planner also. So there are a bunch of kind of cases where as a kind of element of the execution of the plan, the user has some role to play, and the planner kind of is called upon to mediate that in our system.
Yeah, you're right. That is an important consideration because these systems are not fully autonomous yet. And you do want the human not just to give feedback, but to also kind of approve and monitor and oversee things. Right.
I don't know, Raquib, was there anything else that
No,
we
just
missed,
just wanted to add on top of what you just said. So HITL was like wildly ignored until now, but now I do see other people are focusing on that. For example, MCP did add support for HITL from the central planner perspective, and also from the tool perspective as well. So they do have new features about HITL, which is good to see. But eventually we I mean, we are already using kind of that system like HITL, even when we did not have MCP. But it's good to see that other people are also doing that.
Fantastic. So, on that note, Raquib, Jeremy, thanks for a very stimulating discussion. And thanks to everyone who tuned in live. We'll publish this offline in our running podcast, of course. But thanks, everyone, and we will see you next time.
Thanks for having me.
Thank you.
Have a good one.